All right, well, welcome everyone. I'm JJ. Let's jump in and work an example problem. So in this one, we're saying let's determine the moment our force F, the 250 Newton force, will cause about point A. We're going to give our answer using magnitude and sense. So is this a counterclockwise or a clockwise rotation? And then we're going to do it as a Cartesian vector. So we're using I, J, K pieces in here. I'm just going to go ahead and just go for it. So moment, we should know a moment anytime we're working with this. Moment is our force times the perpendicular distance from our force to whatever point we're taking moment about. Finding that perpendicular distance, if I have an inclined force, is actually really hard. I would struggle a ton to figure out what's my perpendicular distance from this force to A. There's probably a way to do it. No one wants to deal with that though. Instead, what we will always come in and do is just break our force up into X and Y components. We know how to do that. That's a pretty doable step for us. Let's come in and give that a go. We could really say, well, I have a Y component here going up, an Fy, and an X component going to the right. I'm just breaking that force into X and Y components, Fx. And then it's going to be easier for me to say, well, what's my perpendicular distance from A to this Y component, or its line of action, an infinitely long line that extends in front of and behind our forces as we're trying to figure out their perpendicular distance. So really from this dashed line to A for Fx, what's my perpendicular distance? Well, if I have an Fx, that's just going to be a Y distance. If I have an Fy, that will always be an X distance that I need to use in there. So let's just come in and try to work this out. So we're going to say anytime we deal with moment, we want to establish, are we doing positive is assumed to be counterclockwise or clockwise. So at the start of every moment equation, we're going to include a positive statement. With positive going counterclockwise, we're summing our moments up about point A. We want to make sure we can keep all of this straight because we're going to get really similar terms down the road where we have a variable that's MA, and I need to be able to find that. We need to keep everything straight in here. I am summing my moments about point A is all that I'm writing out here, with positive being counterclockwise. I pretty much always use positive as counterclockwise. It's easier for me to do one thing and stick with that than to try to rearrange my brain to make it be clockwise as positive. But there's nothing that says we have to do that. If you always do clockwise as positive, go for it. If you want to mix and match, that's fine too. But we'll establish it in every equation. But this is equal to, and then I can look at my X or Y component first. It really doesn't matter. But to figure out, does this cause a counterclockwise or a clockwise rotation? We could think of this like we were spinning our object. If I pushed up in the Y direction here, how would this entire object try to rotate at A? That's easier to do if we have a piece of paper because we could like pin it down at A and physically push our paper up wherever the force is at, and it's going to spin in the right direction. We could also come in and say, well, let's just pretend that I'm drawing a big circle around A. I'm going to start my circle just following that force. So if I were doing this, I could come up right here. My circle will just loop up and around everything. Coming back in at the tail on that. It kind of naturally pushes us to go that way versus like if I come up across my force, I wouldn't come back down to make a circle. It's just an awkward turn then. But so the way that our circle naturally flows, if we start and go along the force, the component will get us the right direction. So I just drew that. It went counterclockwise as I went around. I assumed counterclockwise was positive. So this force, the Y component, is causing a positive rotation. So my Fy should be the Y component of 250. That'd be 250 sine 40. That's an Fy. Let's actually document that. Fy, a force in the Y direction. We've said if we use an Fy, any Y component of force needs an X distance. So really, we're saying, what's that shortest distance from A, from my marker here, to the line of action of Fy? I'm moving in an X direction for that, and I'm moving it 5 meters. So my perpendicular distance here is 5. And again, that's just a dx distance. Fy times a distance in the x. That's not a derivative dx. That's literally distance in the x direction. And then we can repeat that for our x component. So again, we need to figure out, is it counterclockwise or clockwise? So we'll start, and if I go along fx and then draw my circle, I'll be going to the right here. My circle will go up and around everything. So it's also a counterclockwise rotation. So I'm going to add that in, plus fx will be 250 cosine 40 times this time. To get from my x component's line of action to A, I have to go in the y direction, 3 meters. So my dy is 3. Or this is fx dy. Force in the x, distance in the y. But adding that all up, I'm going to get to my total sum of my moments about point A. If I'm using magnitude and cents, this works out to give me, it adds up to 1,378. My units will be force times distance, Newton meters, and for whatever reason, people use a dash when they write moment out. Newton meters. And then we always stick back in, what's the correct direction? I assume positive was counterclockwise. I got a positive number out from that, which means my assumption was correct. It is going counterclockwise. We will always present our moment answers as a positive number and say the correct rotation direction in there. It's just a common way of doing that. But that's our first one. Let's get this as magnitude, 1378, and cents, counterclockwise. If I want to get that to a Cartesian vector, I'd just be saying, well, now it's my sum of my moments about point A as a vector should be, I either take this, any rotation I have in the xy plane, really I'm spinning about a z-axis for that. So this is a z or a k, and it's always going to be that a positive rotation, a counterclockwise rotation, positive k, go together. So this is just, let's actually write that down. A counterclockwise goes to positive k. A clockwise rotation, we would just write that as a negative k. I had counterclockwise, so instead of putting my arrow in, I'll just stick a k on that. And this is 1378 Newton meters in the k direction. If we had this one counterclockwise, it'd be negative 1378 k, and we can get rid of that rotation direction then. Typically, though, we're going to come back to this one. We use IJK a lot of times if we're dealing with 3D moments. Anything for 2D, which is where we try to spend a lot of our time because it's what people would prefer to be working with, which is way easier. We would go back to magnitude, positive, and the correct direction for everything. But hopefully this was helpful for you. If it was, hit that like and subscribe button. Let's get you an A with JJ.